properties of the material and the negative properties of the material after the introduction to the superconductivity. So the first topic after midterm will be the dielectric properties of the material, and inside this topic there are various subtopics such as dielectric constant, dipole moment, polarization mechanism, and so on. Now we will start from the chapter number 7, and the name of this book will be The Principle of the Electronic Materials and Devices by Kasab. So that was from Kasab book. So in this Kasab book, this one is a after. So we will start for our first lecture. The topic will be the dielectric materials and the insulations. So basically, in this first lecture, there will be some theoretical background, theoretical knowledge, and this one is very important for those who are doing your uh, research or thesis on semiconductor devices or photonics, plasmonics. But that means basically those who are doing your research on material science. So first of all, that one is start with a very common formula. That one is the parallel plate capacitor equations. All of we know that the equation for the parallel plate capacitor AC equals to epsilon naught A divided by D, where C is the value of the capacitor and the epsilon naught is the permittivity. A is the cross-sectional area of the plate. D is the distance between the two plates. Now in place, so epsilon, epsilon naught is the permittivity in free space. So we know that sometimes that one is replaced by another constant term, that one is known as relative permittivity, and that one is known as epsilon r. And now this value of this epsilon naught, epsilon r, actually increases due to the polarization effect. Now we will learn what is the polarization effect. So if we want to describe the polarization effect, then we have to start that what is polarization. If we have this one is plus q, and if this one is minus q, and if we consider these two are the two plates, so we know that polarization means there will be some portions will be positively charged and some portion will be negative charged. Polarization means there will be in a single atom or a single metal there will be these dual properties. Now this you will learn that the electric dipole moment, which one is described by the symbol P, which can be measured if we have two charges q plus q and the minus q, and the distance in between these two plates is a, then we can write down this electric dipole moment P equals to qa, where q is the charge, amount of charge, and a is the distance between these two plates. Okay, and this one is known as electric dipole moment. Now, this electric dipole moment is basically depends on the medium in between these two plates and the distance in between these two plates. Okay, and there is another term that one is the dielectric strength. So, whenever look, when the electric field inside an insulator exceeds the critical field, then that one is known as dielectric strength. Okay, there is a very important that means information is there. That one is around 40% utility generator fails to link the insulation failure of the generator, and the dielectric breakdown is probably one of the oldest electrical problems. Dielectric breakdown means there is a breakdown for this dielectric constant, and still now these things have not been that means fully explained. Okay, now this one is basically the background things, and we know both the formulas from our previous knowledge. So let's start from article number 7.1. That one is the matter of polarization and the relative permittivity. So we know that if we have a if we have a capacitor C, and if we have the charge that one is Q naught, then we know that the V equals to Q divided by C from the definition of voltage. So we can write down C naught equals to Q naught divided by V. Very straight formula from the definition of voltage. Now we know that the electric field directed from the high to low potential is defined by the gradient of the potential. The gradient of the potential is E should be equals to minus dV divided by dx. Look, this one will also be explained by another two figures. Let us assume this thing. So look, we don't have any material in between these two plates. That one is the Q naught plus Q naught. That one is the minus Q naught. So this one is defined as C naught. So C naught means in the zero permittivity. Okay. Now, if we insert a dielectric material from the upper portions, then what will happen here? uh, so these two plate will be fully charged, and that means look, if you look at these two plates, then the upper portions, look, this upper portions, the amount of charge is increased, and whenever that one inserted fully in between these two plates, then that two plate is fully charged. So with the insertion of this dielectric material, the amount of charge or the amount of current flow increases. Okay, so yeah, that thing is very clearly explained in this figure 7.1. Now the relative permittivity. So we know that epsilon naught. So C equals to, or C naught equals to epsilon naught A divided by D, right? So if that one is, say for example, C, then that one should be epsilon A divided by D. Now the epsilon R is the relative permittivity. That one, if we divide these two things, that one is C divided by C naught, then we know that Q equals to CV. From the same formula, we can also derive this formula or derive this relationship. Okay, so this one is the definition of the relative permittivity. Now the electric dipole moment, we have already discussed about this electric dipole moment, that if two plate is separated by a distance q, and one of the plate is positively charged and another plate is negatively charged, then P should be equals to QA. So we have already defined these things just before. So that one is the electric dipole moment. So look, here they have slightly explained this thing. So this one is negatively charged, and this one is positively charged, and this one, the distance in between these two charges is a. Now look, always remember there will be a conservation of charge. So the total net charge Q should be equals to zero. Don't forget about this thing. Now if this two charge is that means is separated by a distance x, these two charges separated by a distance x, then we can define that the we can define the terms that polarizability alpha. So then that one is P induced should be equals to alpha E, and this alpha E, alpha, not alpha E, this alpha is known as electronic polarizations. This alpha is known as electronic polarization. Now, from here we can also explain if the number of electrons increases, then there will be a relationship. So we know that if the distance, that is the cover distance, if the cover distance is x, this force, this restoring force, should be equals to minus beta x. You know these things from the classical physics. Okay, and again we know that the from Coulomb's law, that F equals to QE divided by R square. So we can also we can define this thing, F equals to QE, where you know F equals to QE. So Q is the charge. You can define that thing as the electron, and E is the potential. If we have Z number of charge, then that one should be equals to Z. So we can say that these two force should be equal. So that one is Z E E or Q E should be equals to beta x. Now we can define that PE, that means the electronic polarization of PE equals to ZEX, right? So if we put the value of x here, if we put the value of x here from here, then we can find out this thing. Okay. Okay. Now look that we can also find out that ZE or sorry beta x should be equals to ZME. So how they have derived this thing? So that one is FR, right? So force we know that F equals to, just be careful for a little bit there. So F equals to MA, right? And what is accelerations? Accelerations means M is a constant, dV divided by dt, right? And if we take the another derivative, that one is m d square, that is the second derivative of x divided by dt square, right? So that one is the d square x divided by dt square. So if we solve this equation, then we will get x of t should be equals to x naught cos omega naught t, where omega naught is the constant terms, that one is the beta divided by z a m e to the power half or the square root of this. Okay. Look, this term, which one is known as electronic polarization resonance frequency, or this omega naught is known as electronic polarization resonance frequency. So we can also find out the acceleration from here using the second derivative. Okay, using the very classical theory of the physics. Okay. So I think this one is not so difficult for you if you go through this thing. So from there, we can also conclude that alpha E should be equals to alpha E, that means the acceleration, sorry, electronic polarizability alpha E should be equals to Z E square divided by M omega naught square. Very straightforward. Now using this formula, there will be some numerical problems. That one is example 7.1. Please try to solve these problems by yourself. And the next problem should you also should try to solve the problems related to exercise, although I will provide you the exercise numbers which you need to solve. Next one is the polarization vector. Okay, so I think all of you clear how, about this polarization thing. Now if the total volume is V, the total unit volume is V, the polarizations for each atom, that means if there are n number of say for example charge, then we can find out the polarization P should be equals to all the polarizations divided by the volume, and this one is known as the polarization vector. Okay. And what is P1? So we can also write down that P1 plus P2 plus up to Pn equals to P average. That means P average means all the P, all the P, that means 1 2 3 4 divided by n. So P, all the P should be equals to P average multiplied with n. Okay. Now this one is the diagram for this polarization vector. This one is the two plate, and in between these two plates there is an electric field. That one is E, and due to this dielectric materials, there is a here there cause the polarization. I think if you go through these things, it will be easier for you to understand. I'm just clearing only the numerical portions. That means only the formulas. So the next one will be due to this uh, dipole moment. The Indeed, there is a term known as P induced, and the total charge P total should be equals to QP multiplied with D. Okay. So P should be P total divided by the volume. So we can find out the volume equals to V equals to the cross sectional area multiplied with the uh, distance in between these two plates. So if we put these two formulas, then we know that this D and this D will cancel. So P should be equals to QP divided by A, and this QP divided by A is known as surface polarization charge density, which one is symbolized by sigma A. Please remember this thing. This will be important for your further lecture. Okay. Now the P normal should be, we have derived this thing. P normal should be equals to sigma E for a bound charge density. Now the electric susceptibility is Xe, or that one is known as sometimes known as psi E. So P equals to Xc epsilon naught E. Okay. So P induced equals to alpha E. P equals to Np induced equals to NAE. So Xc should be equals to 1 by epsilon naught N alpha E. Okay. So E should be equals to, we know the definition of E should be equals to V by D. If we put the values, V equals to Q by C naught. So then what is the value of C naught? C naught equals to epsilon naught A by D. So both D cancel. So Q naught divided by epsilon naught A. So if we put, if we keep the epsilon naught value constant, Q divided by A equals to sigma E. So this E can be defined equals to sigma naught divided by epsilon naught. Okay. Now this, if we want to find out the Q naught, then if we deduct the total, if we deduct from the total charge minus the polarized charge, so uh, then we can find out the Q naught values. Okay. So sigma equals to epsilon naught E plus sigma E. So what is this epsilon naught E? Epsilon naught E is the uh, that means the uh, surface charge density in the free space, and this one is due to the polarization. Okay. So if we take the if we take the common, then sigma equals to epsilon naught 1 plus x e. So I think those who are doing research in semiconductor or material science, you all of you have found out this sort of equation. Okay. Now I think this one is clear. So from this, from where these equations have come. Similarly, you can also explain that epsilon r equals to sigma divided by epsilon naught. Then epsilon r should be equals to 1 plus xe. Just as simple as that. So if we put the value of xe, then that one is n alpha e divided by x naught. Okay. So there is nothing very critical, but what actually you have to do, you have to just remember the definitions and the always remember from where they have write down this thing. Because if you look, most of the equations are very common to you. Okay. Now I think this will be the end of our ninth lecture. We can also start from our next lecture from article number 7.14. Okay. Okay. I'm also sharing the lecture note from the word, and I think you can go through these things also. That one is, look, this one is the 19th class lecture of word, the dielectric materials. That one is the capacitance. We have already gone through what is capacitance, the formula of the capacitance, the polarization things, then the relative permeability, C naught equals to Q naught divided by V, and the definition of epsilon naught R. So this one is the lecture note or the slide from the word teacher. This one is also available in the in his website also. I have found this thing. and I think this one would be important. This one will be helpful for you if I share this thing. Uh, you can also go through from the book, because in the books everything is in details, but here we just summarize the total things. Okay. So what actually I have covered, I have actually covered is 19th lecture. Look, I have also already covered these things in our class. That one is the polarization P, P average, what is P average, this sort of thing. Okay. That is one is P normal, then susceptibility, the definition for susceptibility. After that, the relationship between these two things. Okay. Then what we have derived? We have derived that epsilon r equals to 1 plus xc up to this formula. Okay. So I think I have covered this 19th lecture number 19, and the in the our 10th lecture we will start from the lecture 20, and that one is the polarization mechanisms. Okay. So we will start from our, yeah, and if we look at your book, our book, that one is the we will start from our, it was 7.1.4. Okay.